Hello everyone. So today I'm going to start projectile motion, right? So first let's discuss what do you mean by projectile. Let's see what do you mean by projectile is. Projectile is the body upon which only force of gravity acts. So what it means basically. What do you mean by projectile? Basically a projectile is a body on which only and only force on gravity acts. So that means only force of gravity. Gravity means downward force. Earth attracts anybody towards its why? Due to gravitational force, right? So that means when anybody come downward, anybody that will through or anybody that will fall under the effect of gravity is known as projectile, right? So that body, that thing is known as a projectile. So second step is that you have to see is nothing other than force of gravity. Means if you consider air friction, no, that body will not cover projectile motion then, right? Then we will not consider that the body is covering projectile motion or tracing projectile motion, right? So means we will never consider air friction, we will never consider resistance or any other force else other than gravity, right? So again I am explaining, a projectile is a body upon which only force of gravity act is known as projectile motion, right? Let me show you some examples, some figures so that you will be more clear. Here you will see a boy fall stone, right? So there are some stones, or you can consider any balls or stone. A boy is falling some balls or stone. That is also a type of projectile motion, but it is free fall case, right? It will come under the effect of gravity, but it is a case of free fall, nothing much. Second, you will see these two types of projectile motion is different from first one. Here boy first will throw up the body and then body will come downward. That means here a body, that means our projectile. What is projectile here? This stone, this body that a boy throw. This is a projectile here, right? So any body that we flow through or any body that we fall down, that is a projectile. You will see here this stone here act as a projectile. So here it is a projectile motion, but this is different type of projectile motion. Why? Because here boy threw up first and then fall down. So there is some angle between a throw down case. There is some angle with horizontal. So this is the case when a body thrown at some angle with respect to horizontal surface. What do you mean by horizontal surface? This is ground. This is horizontal surface. So boy is throwing a body at some angle with some ground, or you can say any surface, right? That is horizontally laid. So that I want to dictate you. There are different type of projectile motion. Clear? So I am showing you now again example that is much clear. Okay. So you will see here water is flowing from pipe. Clear? So there you will see this is a third case as I have done already. A boy throwing a stone upward and then stone will come downward. That is also some angle fired. And here also water is flowing at some angle with respect to this horizontal surface, right? That means it is also an example of projectile fired at some angle. Clear? So at every point maybe velocity will change. At every point gravity effect is there. Clear? So that means here at each and every point body will come fall down or body will throw up. That is nothing our concern. Clear? So we will see that our projectile is fired up or down, right? We will see our projectile is moving with which velocity. We will see our projectile is moving in horizontal direction or in vertical direction. Next thing what we will see at which angle our body is thrown upward, at which angle my body is thrown downward, right? So that is my concern. So basic things are my angle. So first of all I am discussing one by one these cases. There are three types of projectile motion. One is projected at some angle, that means water flowing case that we have seen already. Second case, horizontal projectile, that I will discuss later after this lecture, right, in next session. Third case is free fall, that means when a body is at not some angle fired, just throwing down, just falling down, as in first case you will see. This is free fall case, right? And this second case is body is projected at some angle, right? So this water flow case is also an example of projectile fired at some angle. I hope at this point you will be more clear that there are three different types of projectile motion. One by one we will discuss this. First of all, I am discussing here the case when projectile fired at some angle, right? So I am showing now animation. First animation is, you will see here, I am showing here one by one these velocity vectors. So what you will see basically, you will see there is no angle, right? Here it's 61.2 degree. I can change my launch angle also. I am saying that I am changing my launch angle, I am decreasing my launch angle, I am increasing my launch angle. So that means at which angle I am firing my projectile, I will change that angle. First thing. Second thing, I am showing now velocity components. So these are velocity components. This is Vx and above one is Vy, right? So Vx is my horizontal velocity, Vy is my vertical velocity. So what do you mean by Vx and Vy is that I am firing my projectile at some angle, that means there is some resultant velocity, right? So you will see here, this is my resultant velocity, V vector, clear? This is Vx, this is Vy. So this V velocity is resultant of this velocity vectors Vx and Vy. Next thing. So second thing is, if I am changing my launch angle, will velocity component will change? Yes, it will change. I am changing my launch angle, my velocity component will change. You will see in this animation, right? So next thing is, my launch angle is clear now. Second thing is, if in starting I am at time t equal to 0, now I am increasing my time, I am increasing time, I am increasing time again. So you will see this body will cover projectile path. I will show you that how it covers, right? So as I already discussed, you will see this is projectile motion path. Now did you notice one thing? See here, when I am changing my time, my Vy component will decrease, vanish, again start, right? So just starting, Vy is there, again you will see Vy will get shorter. At this point it will disappear. So what it means? Means at maximum height there is only horizontal velocity Vx will act, right? When again I am changing time, my both component will play role, right? So that means my horizontal component velocity is changing when a projectile fired at some angle, but my vertical velocity disappear, again disappearing. See here, my velocity component both here, again changing, Vy diminish, but Vx is there. So you will see here in this values, my velocity Vy is changing again and again, but my Vx is constant. See here, my Vx is never changing, 16.63, still 16.63. Where you will get 16.63, again 16.63, but Vy is changing again and again, negative values, positive values, Vx is constant. So what you conclude from this animation? Horizontal component will remain as it is, value will never change, but Vy is changing again and again when I am projecting a projectile at some angle, right? So first thing is this. Second, if I am changing my launch angle, my velocity component will also change. That is also the thing, right? So I hope at this point you will understand the projectile motion fired at some angle. In next session, I will dictate you mathematical concept, mathematical derivation based on this projectile fired at some angle, right? I hope you enjoyed this lecture. Stay safe, take care.